Assalamualaikum. My name is Nor Syahila Bt Nordin, and today I will explain about the video that demonstrate the basic layup technique to fabricate fiberglass laminate. This process also known as the wet layup technique. Before we start to do this demonstration, we have to control the proper amount of the resin content for the optimum performance. Regardless of fabric types, oversaturated versus low resin content will exhibit radical difference in mechanical properties. Considering vast type, the fabrics of and the weave style, 35% resin content generally yield the best balance of mechanical performance and also the aesthetic value.
Firstly, a 10 ml coat of impregnating resin is applied onto a 4 ml plastic polypropylene film as the carrier for the impregnated fiberglass. Before we continue, we have to take note that the rapid wet out of the fiberglass fabric is 2500 CPS mixed resin viscosity. Next, air is displaced outward instead of forcing the resin through the fabric, which will entrap air bubbles. This technique will help uniformly disperse the impregnating resin with a minimal agitation, thus reducing wave distortion. Next thing to do is we have to equally apply a coat of resin per layer or ply of fiberglass cloth to yield uniform resin distribution. The resin content of laminate is a critical aspect that will dictate its ultimate mechanical performance under the load. Structural laminate require lower resin content for the higher mechanical performance, and vacuum assist impregnation or flattened pressure curing are other methods of incorporating the resin to the fiberglass. Continuous pressure is applied on the laminate until the resin is cured. Pressure cure laminates demonstrate superior performance compared to this basic wet layup technique, but it requires the use of specialized equipment. Fabric density, wave style, and surface finishing are other factors that dictate the fabric to resin ratio. Regardless of the laminate's intended to use the void content or porosity within the composite matrix is detrimental to its ultimate quality and also their performance. We must observe the working time of the resin system and apply the mixed resin within half of the stated working time or pot life of the resin system. This will provide the time needed for the resin to wet out the fabric truly and create a homogeneous composite. The total impregnation time is 10 minutes. We have to use a silicone roller or a flexible spatula to consolidate layers and debug the fiberglass in a unitized laminate. This will also remove the air bubbles and trap within the laminate matrix. We have to avoid distorting the weave pattern as much as possible because distortion will create a weak spot where the mechanical failure will propagate when the load or sudden force is applied on the laminate. Next, the mold release is applied on the glass sheet, which will serve as a top cool plate that will provide the flatness. A harder rubber roller is used to further consolidate the laminates and eliminate any entrapped air pockets. Then, The impregnating resin will continue to equalize throughout the fiberglass fabric as long as the resin is still in its liquid phase. And we have to allow it to cure for 24 hours at the room temperature. Upon the cure, peel off the plastic films and then delaminate the cure composite from the glass cool plate. The 4 plies of 9-ounce satin wave fiberglass fabric impregnated with 2500 cpm medium viscosity resin. Target resin content is 33% by the weight. They are the plastic film side and also the glass cool plate side. The cure laminate can be trimmed by the guillotine, shearing, water jet cutting or machine saw to size. Note that the durability and toughness laminate when flexed. More than 45-degree bend, no fracturing, and no delamination rebound to its original shape. That's all from me. Thank you and hope you like it.